If you want to make a vector of points in an unbiased random direction, use a normal distribution, because I said so. Okay. I was just entertaining myself there. Here's my reasoning for that. It's a good question. First of all, let's draw the two distributions. This is a uniform distribution. Do you agree? This is usually 0, this is usually 1, although you can do uniform between other values as well. And this is a Gaussian distribution-ish. It doesn't go below there. It's not quite that wiggly. Leave me alone. Right? Gaussian, also known as normal distribution. Now, if you fill up two values from a uniform distribution, so we draw x and y, it will basically fill up a square where this is 0, this is 1, x is 1, this is y is 1. And if you pick from a uniform distribution and do random points, they'll basically be distributed kind of like that. They'll fill up the box, right? Okay. Now, this much I think you can get from your own intuition. But from a lecture, I told you that if you draw values from a Gaussian distribution, they'll end up distributed kind of like this. They're a little more dense in the center and less dense outward. Basically, this is a multivariate two-dimensional Gaussian distribution. Okay, I've gone from 1 dimension into 2 dimensions now, right? Now let's go from 2 dimensions into 3 dimensions. And I'll just leave that one there. Now it sticks out of the screen too. Now we're in 3 dimensions. Uniform is making boxy things and Gaussian is making Gaussian-y things, right? Okay, well now suppose we start at the origin, which is right here for that one and right here for this one, and we pick one of these random points. Can you visualize in your head that in the box we're more likely to point at one of the corners than we are to point at one of the sides?
Yeah,
and with the Gaussian one, we're equally likely to point in any direction as any other direction. Therefore, the uniform is biased and the normal one is unbiased, is kind of the end of it. It is counterintuitive, and that's what it is. Ah, so if we used a vector and we picked a random angle, and then it would want to be uniformly distributed. That is true. In fact, if you pick a random value from a uniform distribution, the angle with the origin will not be uniformly distributed. Whereas if you pick a random position from a normal distribution, the angle will be uniformly distributed. Now, to be clear, that only works in 2 dimensions. If you go into 3 dimensions, we've got 2 angles to work with, and those 2 angles interact in kind of a funny way, because you can't just pick 2 random angles uniformly distributed, or else you end up with bias in where the final vector ends up pointed. And so that's a good way of looking at it, only in 2 dimensions. I don't know how to generalize it beyond that. So we kind of have to, for filling arbitrary vectors, filling them with normal values is kind of the thing to do. And again, I do have to sort of apologize for asking a question of, did you memorize what I said in lecture? But that's what this one is. Okay, match the problems below with their corresponding algorithm. I'll do that later. Okay. Which operations are essential in an effective genetic algorithm? After I passed this one out, it occurred to me, dang, that's subjective. I regret that question, but, well, I did it. So by effective, I meant one that would work. I think that's what effective is generally understood to mean, but what I was going for is, what do you really need in a genetic algorithm? And don't tell me all the things that are great ideas. Do you need in a way to evolve metaparameters? No, I demonstrated for you that it works without that. So I think it's pretty clear that's not necessary. Is it a good idea? I think it is. At least it is in some situations. People who tried it with and without in this problem or in the homework assignment, seemed to find that it didn't actually buy them anything. So maybe not, but in planet Earth it seems to do useful things because, for example, we don't use genetic algorithms in our brains. We use other techniques that are much more effective, and it's a darn good thing because we'd be very slow thinkers. So we've effectively evolved better ways of operating, and that's kind of a good thing. That wasn't a very great proof, but suffice it to say, I think it's a good idea. Do you need some way to ensure that the best member of the population never dies? No, in fact, that's a bad idea. It's important to have the best member of the population die, and that's counterintuitive. Why is it important? Because if the best member of the population never dies, he kind of becomes a dictator that chains your population to the local optimum that he first finds. And that happens in the real world, too. For example, copyright. Really great way to promote innovation. And then the music industry decided that that's the holy grail of all truth and everything must be copyright. And now we're kind of stuck trying to figure out how to make the internet and copyright mesh with each other. And innovation versus copyright is a big nightmarish mess. And all kinds of legal issues are rising up over that. Right? Is that an example of this? Feels like it to me. That was probably too politically charged to be a good example. But it's an interesting thing to debate if you want to. Okay, some way to select more fit members of the population for survival. Yes. That's kind of what evolution is. This is, I mean, you've heard the mantra survival of the fittest, right? I don't think there's any way to do evolution without doing that, or something that would be classified as that. So I'm going to say that's pretty essential. And if you're killing people off and not letting anyone survive, well, your population is just going to die. I think you need this one too. Do you agree? Okay. Finally, some way to approximate the effects of continental separation. Good idea. Does it have to be parallel? No, but it's better if it is. Do you need a specific objective? Yeah, that's true. Does it have to be a specific one? So I know I'm going to get torn apart on the technical debates about this one. I think the word that stood out here was specific. And you do have to have it coded up, which in some ways means it has to be formalized. Does that mean it's specific? Kind of, yeah. You do have to have a specific way of deciding which ones are better. So what I was looking for was, hey, in our programming assignment, I had really emphasized that if you tell it too much what you're looking for, it will go right there, rather than achieve general ways of solving it. So that's what I was shooting for, is we had talked about that. Yeah. This is a case where I should have done what I did with my these things, where I said this one as opposed to that one. And I would have said a specific objective as opposed to a general objective. Okay, well, that's a terrible one, and I put it there, so I'm in trouble. But there is a valid point to be made with it, and the valid point is the one where if you tell your genetic algorithm this is the right solution, it will just evolve that solution rather than evolve general capabilities that include that solution. Do you need a way to promote diversity?
Absolutely. Yes.
Yes, you do. Otherwise, you sit around testing the same point over and over and over, which is obviously the point. Do you need a way to identify which members of the population are well suited as mates? Yeah, so while this is a good idea, we have demonstrated that it works without it. So I'm going to say it's not essential. We are getting kind of close to the essential line. So yeah, well, and speciation's not necessary, but probably a good idea. I'm going to get away from this problem because I'm feeling the anger level of my class rising and it's about to swallow me. Yeah. Okay. A well-designed implementation of uniform cost search would separate implementation of the solution from the problem. Oh no. This one's equally subjective. I went with S, P, P, S, P, P, S, S. That's what I put. Suppose scientists estimate that each year there's a 1 in 8,000 chance that an earthquake of sufficient magnitude to completely destroy Northwest Arkansas, the Union Building in Northwest Arkansas. Okay, policy A covers up to 5,000 of damage with this cost. Policy B covers this much with that cost. Now, in the event of an earthquake, the insurance company will not pay more than the cost of rebuilding the building. In other words, even though policy B says it covers 20 million, it really only covers 10 million. Is that how you read it? That was a bunch of words without a purpose, except to be a little bit more realistic. And I'm not quite sure why I think that's important, but in the real world, a lot of people learn how to do these AI techniques and then don't know how to apply them in the real world. It's kind of important to know how to apply stuff, so I want you to know how to apply stuff. There we go. Let's draw a tree. You're going to choose policy A or policy B. That was pretty clear, right? Because the question says, which policy is a better deal? Okay, I will confess, in the real world, there is the option to not buy insurance. So that's a valid point. And if you did it correctly with that third option, I'm pretty sure the grader will have simply not looked at it. The key was written such that there were two choices, A and B. And in each of those, there are two cases, which are there could be an earthquake or no earthquake. Do you care which way is left and which way is right? We'll say left means there's an earthquake as represented with the letter E. If you want to choose policy A, you're going to have to pay how much? $1,200 a month? Yep, that is true. That is how insurance works. And if there is no insurance, then you're going to spend $2,000. Okay. Now, if you spend the $2,000 and there's an earthquake, how much do you have to pay? Nothing? And nothing. And if there's no earthquake, do you have to rebuild your building? No. And if there is an earthquake, what do you have to pay here? $5 million.
I mean, they're all there's no positive numbers.
So you can do utility theory by calculating utility or by calculating cost. If you do utility, you better maximize it. If you do cost, you better minimize it. And it doesn't make a darn bit of difference which you do, because minimizing a negative is the same as maximizing the positive or vice versa. So which do you want to do? We did call it utility theory. Then again, we save a line. Okay, we're doing cost. Minimizing cost. I'd have to draw a line there and there and there, and I'd better put dollar signs there. Did you know these aren't actually dollar signs? True dollar signs have two lines through them. These only have one line through them, which is technically a string symbol. It's been formally changed?
Absolutely.
Oh, wow, I'm so not up to date on the latest specification of symbols. Okay, so be it. I am truly not a symbologist, if such a thing even exists. Just for fun, let's add the option of no insurance, which is not in the answer, and no one was expected to do that, but let's see what will happen. If you have no insurance, does that negate the possibility of there being an earthquake? No. And so that's going to put a 0 here, and that's going to put a, what, 10 million there? Okay. Cool. Just because we can. Red means that's not supposed to be there, but could be there if you want it to be. Okay, what is the expected utility of there being an earthquake in this universe? The one where we bought policy A. It's going to be the probability of an earthquake, which was 1 out of 8,000, times 5 million. So 1, 2, 3, 4, 5, 6 divided by 8,000 is $625 worth of utility. So I'll notate that by saying negative $625 of utility, because, wait, paying is positive. Yeah, I better do it. Okay, you're right. So that's going to be positive. They're going to get added together. So the overall cost of choosing option A is going to be $1,825. Do you agree? There's a bunch of numbers not quite well described, but hey, there's audio in the video. There you get it. So the cost of choosing option A is $1,825. What's the cost of choosing option B? $2,000. Which would you like to pay, $1,825 or $2,000? Less is better, more is worse when it comes to cost. If you do utility, you negate it all, and then we find the higher utility. Either way, choice A is better, therefore the answer to number 15 is A. I'm going to claim that will arrive at precisely the same answer. Did you arrive at the same answer?
I did not average.
Ah, okay. Well, let me put it this way. If you wrote an A right there on this problem, you got it right. If you wrote a B right there on that problem, you got it wrong. And the next problem, asks you for the cost of policy B, and so you'll end up needing, basically, there's the answer to the next problem, right? 1825, because if this one had the same cost as that one, then it would be ambiguous. If you put 1824.99, you should still get full credit, because that would be actually having incentive to go over to this one, as opposed to 1825 being, hey, it's either way. Anything less than 1825 should make you choose this one. If you did it some other way, that's fine. I claim you'll still get the same answer, unless your other way is wrong. And so we'll dig through that. Okay, so yeah, if we do 10, 1, 2, 3, 4, 5, 6, divided by 8,000, cost is $12.50, which is less than 1825. In other words, insurance companies are ripping us off. And are we pissed? Oh, yes, we are. Well, okay. So if you did extra work and showed your work, then really the only thing I've got against you is the technicality ding for not reading the question more carefully. And that's certainly not worth losing all the points on all of these problems. So yeah, after you see your tests, come argue with me.